Okay, hello everybody. So we're moving on to the formal proofs that you guys are actually supposed to learn as part of the curriculum for Math 3. So a lot of the stuff that we've been doing so far has been review, and now we're getting into the real content. So we're gonna do some notes and we're gonna do some practice problems, and then you guys will have some homework tonight with those. So here we go. So each statement. Okay. You must have a reason. Okay. You can't just like say that something happens and not have a justification for it. Okay. So we're going to start by stating the given information. Okay. And we'll end by stating the conclusion and which congruency theorem proves it. Okay. Also, feel free to just do this on notebook paper. And I know that these proofs are kind of a lot to write out, but um, so I'm sorry. Um, but yeah, you can always just write this stuff on notebook paper. So take your time, pause the video, get what you need to done. Okay, so there are two little properties that we want to remember here. The first is the reflexive property. This is when an angle is congruent to itself. Okay. Or you could also have a side is congruent to itself. It's with when anything is congruent to itself. Okay. But in terms of triangle congruency, we're looking at angles and sides. So when a side is congruent to itself. I feel like these little statements blend in a lot, so I'm gonna like highlight them so that you guys can see that these are properties that are not connected necessarily to the proofs that are directly below them. The next one is alternate interior angles. So these were in the notes that I didn't make a video for, but I did post for you. This is a Math 2 concept. So alternate interior angles are angles when you have, that was a horrible transversal line. You could have a transversal line like that, but I don't really want it to look perpendicular. So maybe if you have two parallel lines, okay, and the little symbol for parallel is this little arrow on the line. If they have matching arrows, then they're parallel. And then we'll have a transversal that goes through like this. Alternate interior. So alternate means that they need to be on opposite sides of the transversal, and interior means that they're inside the parallel lines. So an alternate interior set of angles would be, for example, these two right here. Okay, there are two more on this picture. I'm not going to draw them because I feel like it gets confusing when I start drawing multiple ones. I did it on my one from last year and it just looks a little bit confusing. The other two would be this one and then that one are congruent. Oops, I kind of threw it in. So that's where they are. And that's one example. There are two sets there. Alternate interior angles are congruent, if I can spell, congruent if the lines are parallel. Okay, so you need to know that the two lines that your transversal is going through are parallel first, and then you know that those angles are congruent. Okay, so those are two properties that are going to be especially helpful in these notes. Sorry. So let's go ahead and practice some of these proofs. We have two triangles right here. So the first thing is the first two things are just given statements. Okay. And then these given statements are going to correspond to the angles that are marked and the sides that are marked. So the first two angles are angle Q and angle S. So angle Q is congruent to angle S, okay? We know those two are congruent because it's given in the problem. There's like a little mark here. I'm going to white it out so that it's easier to tell. All right. The second thing is that line PQ is congruent to line RS. So PQ is congruent to RS. Okay. And that's this line right here and that line right there. Those two are congruent because they're marked on the paper. The next thing is that QS is congruent to itself. This is the reflexive property. These two triangles share this side right here. And so we're just saying that those two sides of those separate triangles are the same, but because they're shared, we label them as QS is congruent to SQ. And this is by the reflexive property. Okay. And now I'm going to zoom in because this gets really tiny. Oh. Okay. Now notice that we have a side and then an angle and then a side where the angle is in between the two sides on both triangles. This means that those two triangles are congruent by side, angle, side. Okay, so that was our very first one. We've shown that PQS is congruent to RSQ using the given information in our triangle theorems. Okay, so let's move on to the next one. Basically, I'm going to do the whole front with you, and then I'm going to give you guys a chance. Ooh, sorry. I'm going to give you guys a chance to do the back on your own, and then check yourself. Okay, so we're going to move on to the next one. Okay, excuse me. So we're given first, and this is important up here, PQ, these two lines mean that they are parallel. So PQ is parallel to ST. So I'm going to do my little arrow that shows that these two things are parallel. And I'm also going to highlight this given information so that you guys can see what I'm talking about. Okay, so that given information corresponds to those markings. It means that they're parallel. Okay, then it also says that PR is congruent to TR, and that is these right there. Okay, so PR congruent to TR given. Okay, the only other thing that's given is that PQ and ST were parallel. So we're going to go ahead and write that here. Okay, so these two are the orange and green given pieces of information at the top. Then it says angle P is congruent to angle T. So it's talking about this angle right here and that angle right here. Notice that those are inside of my lines that are parallel. This segment was parallel to this segment right here. P and T are inside of those parallel line segments. So it probably has something to do with interior angles. They are also on opposite sides of this transversal that they touch right here, the PT line. And so this means that these two angles are congruent by alternate interior angles. Okay. The next one is that PRQ is congruent to angle TRS. So PRQ is this angle right here, and I'm putting two arcs in there because it's a different angle from angle P and angle T. The next one is TRS. Now, these two angles, if you remember, they are directly across from one another. They share this vertex right here, so they